In Embrio, your programs are made out of agents. All agents in the project are always updating, so you don't even have to think about most of the challenges of parallel programming. The files with the pink icon in the project tree are agents. The structure of your project tree is for your organization only and does not reflect how agents are connected. An agent is a group of nodes that all refresh at the same rate and do one job. In this video, I will expand on the blink example from the last video. Everything in an Embrio project should be encapsulated by an agent. In the blink project, everything happens in one agent. This is only okay in very simple projects, but what if you wanted other agents to be able to control the LED? To allow this, I'll create an agent that encapsulates the LED. I'll start by cutting the LED node and pasting it into a new agent named LED. Clicking on this little button to the right of the input gives it a red background, which means it is exposed and available to other agents in the project. To illustrate this, I will show both of the open agents on the screen. I'll rename the original agent Blink, and then drag the LED agent onto it. This exposes the LED agent to the Blink agent, so the Blink agent can connect to its inputs and outputs. Connect a switch to it, and the LED blinks again. An agent encapsulates something, be it a resource like this LED, or a servo, or something higher level like the Blink action. The way agents interact with each other is mostly by turning on or turning off other agents. To make this easier, I'll add a suppressed activation node from the Inputs menu. This node has two exposed inputs, activation and suppression. When the activation input goes up, so do the activation and suppressed activation outputs. Other agents can also connect to the suppression input, which subtracts from the suppressed activation output. When they raise this value, the agent is turned off. I'll unexpose the activation on the LED node and connect the suppressed activation node to it. To further illustrate the concept of encapsulation, I'm going to remove the LED from the Blink agent for now, and make a new agent which connects to the LED. I'm going to set the refresh rate of the LED agent to 64 updates per second. I find this is enough to make fading smooth. I'm going to change the new agent's refresh rate to something low, like 8 times per second. If I graph the LED's activation, you can see that it is not very smooth and has steps because it is being updated by a slower agent. To fix this, I'll disconnect the LED node and add a value lag node between them. If I bring up the lag value, the output will follow behind a bit, smoothing out the input value. Now agents of any refresh rate can connect to the LED agent and its value will remain smooth. Now that the LED is encapsulated, I'll finish the Blink agent. Right now the Blink agent is always running with no way to turn it off. Again, I'll add a suppressed activation node. The Blink action can really only be on or off. It can't be on to some degree. We'll use another agent to control the brightness of the LED later. So I'll click the Clamp Output checkbox on the suppressed activation node. This locks the suppressed output value to 0 or 1. Connect the suppressed activation output to the activation on the LED node and change the blend mode from Add to Multiply. This part is very important. There are 3 blend modes on a numeric input: Add, Multiply, and Average. By selecting Multiply, the value of the blink state is passed through only when the suppressed activation is 1. When the suppressed activation is 0, because multiplying a number by 0 returns 0, the blink value is turned off. This is a very common concept in Embrio. To wrap up the introduction to agents, I'll emphasize a few points. Agents are small subprograms that each do one job. All agents are always running, meaning their nodes calculate new output values as many times per second as the agent is set to. Because of this, you should use as low a refresh rate as you can to conserve processor cycles. Agents that touch physical devices like LEDs, motors, and sensors might need to refresh at a fast rate, while higher-level agents that make decisions can update slower. Agents communicate mostly by turning on or turning off other agents, or in Embrio terms, activating and suppressing. An agent should only be doing one thing. If an agent is doing more than one thing, it might be a good idea to break it down into multiple agents.